The equations of motion revision, I'm going to stick to the equations that you see here on the left-hand side. Please also remember that this one here, you have to be very careful to use because it's often used with the wrong signs and then it gives you the wrong answer. So you will be able to use the three equations there to solve all your problems. This one is not taboo, but please try and avoid it, except if you know exactly how to use it. These ones I'm not going to use, but also they are on your information sheet and you are allowed to use it if that's what you're comfortable with. These points we went through when you did this in class, but please remember that if the velocity and the acceleration is in the same direction, then the object will be speeding up. So if I'm moving west and I've got a force accelerating me west, it makes logical sense that I'm going to speed up. Please also use the word speed up, left, right, up, down. Use English when you answer these questions. Don't try and be fancy and say in a negative westerly direction when you mean east. Now here, the velocity and acceleration in opposite directions would then mean it slows down. So that means the force is applied against my motion, so it's going to make me slow down. Then certain things that you need to read from the question. You need to read come to rest, start from rest, dropped, thrown. These words need to lead you to whether the initial velocity will be 0 or not, or the final velocity would be 0 or not. And then, very important, if you are moving with an object, so if I'm throwing a ball out of a car while the car is traveling, the ball starts with, or dropping something out of a car while the car is traveling, the ball starts with that velocity that the car had. Newton's first law is applied here because it will keep on moving with the velocity it's moving unless a net force acts on it. So if it was moving with the car, it's going to keep on moving with the car until friction or gravity or something else works in on it. Another important point, time is a scalar and therefore we are going to use positive times. If you end up with a negative time, don't just make it positive. That should lead you to the fact that you've assigned the direction wrong for one of your variables, and most probably it's going to be your displacement, because often we forget that displacement up and displacement down also needs to have a specific sign assigned to it. Now for these variables, I use the acronym UVAST, but you can use whatever you want. When you read your question, I would say read it fast to get an idea of what's going on, then read it while you are filling in these values. And you will see that it leads you to specific equations. If S is not needed and also not asked, it will lead you to the first equation. If T is not needed or asked, it will lead you to the second equation, and then the same for V. So the thing that's actually missing will lead you to which of these equations you need to use. So for example, I'm not going to do the example, I've already done it, so you can just quickly look how this works. If they give you the question about a car starting from rest, you can see that U is 0, the acceleration was given, the distance was given, and they're asking you for the velocity. So these four variables will be needed, but T not. So that leads us to the fact that we're going to use the equation without T in it. You write down your equation, please the way it is, don't change, do the algebra now, don't change the equation. Fill in your variables into the equation as it is, and then do the maths. The maths is only going to give you 1 mark. So if you mess it up here, you're going to lose 2 marks instead of 1. So rather just substitute your values into the original equation. Another example, you can see here the initial velocity is given as 15 meters per second. They tell you that he's slowing down, so the force is against the motion, so you need to remember that it's going to be negative. And then they say to stop. So if it's stopping, the velocity, final velocity is going to be 0. The time is asked, and this time the displacement is not needed. So it leads us to that first equation there. You write down the equation for a mark, you fill in the correct values with the correct signs, and you will end up with a positive time. If you didn't assign the negative sign there, you will end up with a negative time, and then that should guide you and say, let's go check. Didn't I maybe do something wrong? Now, in all these equations, you will see A is always there. So the note I made here is very important. We only work with one bit of motion. So what I mean by one bit of motion, a bit of motion that has a constant acceleration, therefore a constant net force acting on the object for that specific time. If something changes, you go and write a new set of variables and you decide what about the first set can still be applied to the second set. Also remember, if time is your unknown and you need to use this last equation, there's a t and a t squared, and you can end up with a quadratic equation that you have to solve. Now, all of you are very good with your maths, so it shouldn't be a problem, but you can use the quadratic formula or else get used to your calculator. The grey calculators can solve for x, so make sure you know how to use your calculator to solve this quadratic equation. Then we have to look at vertical motion. Please, for vertical motion, note what the question tells you. Is the object being thrown upwards, dropped down? All of those things, please make a mental note as you're reading the question. Because it's something very important for vertical motion is if the object is in free fall. Now remember what I mean by free fall. There's no other forces acting on the object. So it's only the force of gravity pulling that object, and this is important, pulling that object down. So this variable will also always have the sign of whatever you assigned down to be. Some people like to just always make it negative, but remember that's not a rule. You need to remember that it's always downwards. Now, if you think about an object being dropped, if the object is just dropped downwards, then you know that u is going to be 0. So when you look at a graph of the velocity versus time, then you're going to start here at 0. And please, we're going to use a ruler because the gradient of this line gives us the acceleration. So it needs to be, if you decided that down is positive, then the gradient is going to be positive, but it needs to be constant because it's going to be 9.8. Where will it reach its fastest speed is just before it hits the ground. So its fastest velocity will always be just before it hits the ground. So that would be for an object that is dropped. If the object is thrown upwards, still deciding that the down is positive, then this would be your graph because then you start with the velocity there. Now, if it was negative, it would just be the other side. So then you would start here and your gradient would be negative, showing 9.8 negative. Your velocity will be increasing in the negative direction, but all the concept still stays exactly the same. Now, that is for an object that is dropped. Now, or downwards, and thrown upwards. Now, if we're saying that the object is thrown downwards, and we still decide that down is positive, well, let's make down negative now. So let's say down is negative, and that means we're starting with a velocity downwards that is negative. Then my velocity is going to increase in the negative direction. So that means I'm starting there and it's going to increase in the negative direction. So similar to what we had being thrown down and deciding the down is positive. If you're throwing an object upwards, now be careful. If an object is being thrown upwards, it's going to leave your hand at a specific speed. So it's going to have a velocity. So whether it's negative or positive doesn't matter. Let's say we decide that down is negative. So we're going to start here with a negative velocity. Now, if you're throwing an object upwards, it's going to slow down, slow down, slow down. And this point is important because when it crosses the axis, it means your velocity here is 0. So that's your slowest velocity. But that means it's turning around at the top of the motion and then it's speeding up again, but now in the opposite direction. So if I was going to draw this, this is the velocity that it starts with. It slows down, stops, speed up, speed up, speed up. And if you're catching it at the same place and it's only the gravitational acceleration again, then this gradient must be constant. Doesn't matter where you look at it, it's still going to be g, which is 9.8 meters per second. And in English, just write downwards. Then you know you've got it right. Now, often you don't just get one motion, they give you bouncing objects. So if we look at this object that we had here that was thrown upwards, so I'm going to just draw that same line again. So it was thrown upwards and there we go. So again, it's a velocity time graph. So please remember, even if it's a sketch graph that you have to draw, you still have to label your axes. So it starts with the velocity, and we decided that, we decided that up is negative here because we started with a negative velocity. So up is negative. So I hope that's what I said in the previous slide, but up is negative. So then as it reaches this point here, it is now stopping. So that's again the top of the motion there. So it stops there, then it speeds up until it reaches the speed again at the hand, and it might go even faster because it might even travel further down to the ground. So just read your question nicely. But now what's going to happen here? So it has its fastest velocity just before it hits the ground, and then it leaves the ground. When it leaves the ground, if it's an elastic collision, it will leave the ground with the same speed in the opposite direction. So you will have that you're now starting here at a negative. Often there's some energy lost and you will leave with a velocity that is a little bit lower. So they can actually combine this with an energy question. But as soon as it leaves the ground, it needs to be a straight line again, because the gradient is still going to be 9.8, and that's what you need to remember. Now it's leaving the ground at this point here, so we are here now. It again goes slower until it reaches the top, and the top again is at that point there. So these points here are those points there. Always when it reaches the top is where velocity is 0. I say v top is 0 so that you know what you're talking about. But this gradient and this gradient are both going to be 9.8. And because we decided that down was negative, you will then see that our gradient is going to give us a positive value. No, sorry, I mean up. Oh, I'm confusing my up and down. We decided that up was negative. Remember, it was thrown upwards. Up was negative, and therefore down must be positive, which is perfectly right because that's going to give me my meters per second there. So there are the extra bouncing ball questions that I posted that I'm going to give you again, but I'm not going to look at that example actually. You've got a lot of examples and I'm going to give you some past paper questions to rather look at. So this is the end of motion.